Okay, so we're now on the integrals of exponential functions. So we have two formula for the exponential functions. So similar with the one that we've used in finding the derivative of an exponential function. So the first one, an exponential function that involves a function, okay, whose base, okay, is a constant. Okay, so if you have a constant base and then raise it to a certain variable, so the integral of au du would be equal to a raised to u all over ln a plus c. So, if you could still remember before, so let's say we want to find the derivative of a raised to x. So its derivative is a raised to x and then ln a dx. Okay, so that's how we find its derivative. However, if we want to find its integral, so baligtad siya. Instead of a multiplication of ln a, so it would be a division. Okay, so that would be au over ln a plus c. But we have to take note here that a should be positive. Okay, so a should be positive or a should be greater than 0. So likewise, so we have another exponential function. We have the integral of e raised to u du. And in here, our base is e. Okay, so we're in e has an approximate value. So e raised to 1 has an approximate value of 2.718. Okay, so 2.718. So for its value. Okay, so the integral of this, so eu du, so would be equal to au plus c. So once we derive u, and then we were able to get the entire part of the integrand or the rest of the integrand, then we can use the formula eu plus c. But our examples right now are not just limited to this formula. So we will be incorporating some of the formula that we've used. So particularly the power rule, or if it is possible, the natural logarithm formula as well. So let's have our first example. So our first example states that what would be the integral of 5 minus 2 e raised to x dx? What's the integral of 5 minus 2 e raised to x dx? So to find this integral, so we can incorporate the sum and difference rule and the coefficient rule of integration. So since we have 5 there, and then we have minus 2 e raised to x, so this would just be simply 5, the integral of dx, then minus 2, the integral of ex dx. So this one uses the constant formula or the constant rule for the first term. And then for the second term, so we have the integral of eu du as just simply eu plus c. So in here, our u is x, so its derivative is dx. So which is just a direct use of our formula. So in short, the integral of this would just be 5. So in the integral of dx, it's x. Then minus 2, the integral of ex dx, it's ex plus c. So we just have now 5x e minus e raised or 2 e raised to x and then plus c. So that's on how to use the formula for the exponential function. Okay. Clarifications? So feel free to interrupt, okay? Okay, good. The second one. So the second one is an exponential function with a base of a constant. So 7 raised to 2x plus 3 dx. Okay. So in here, so it would appear that we have a value for u. Okay. So ang u natin is the exponent. The variable exponent 2x plus 3. So we derive this one, so its derivative is 2 dx. So the derivative of 3 is 0. So that is our du. And remember on our formula that the integral of au du is equal to au over ln a plus c. So now, so we use this formula. So that the integral of AU, so AU, our A is 7, okay, our U is 2x plus 3. So 2x plus 3. And then what is our du? So the derivative is this one. So 2 dx. 2 dx. So comparing this one, okay, the application of the formula to that of the original integrand. So again, there's a difference. So a difference of, that's a difference. So may sobrang constant. Tama ba? So what would be our neutralizing factor? It will be
7/2.
7/2. Ano ang sobra? Ito lang, di ba? It's just the 2. So 1/2 lang ang neutralizing factor natin. So we leave the 7. Okay? So 1 all over 2. So 1 all over 2. So, ayun na yun. So, nakaporma na siya no? The integral of AU du. So now, so we integrate. So using that formula, so A then, or 1/2, then multiply it with A. Our A is 7. So 7, our U is 2x plus 3. And then over ln A. ln, our A is 7. So ln 7, and then plus C. So we use this formula. So AU over ln A plus C. So our answer then would be 7 raised to 2x plus 3 divided with 2 ln 7 plus C. So we are okay with this one. However, if you want to express your answer in a different manner, so that would be possible as well. So we'll have 7, 2x plus 3, then over ln. So using the properties of logarithm, so we can make this one as 7 raised to 2. Right? So 2 ln 7 is the same as ln 7 raised to 2. So plus c. So which would make it 7 raised to 2x plus 3. So divide it with ln 7 squared would be ln of 49 plus c. So an alternative way on how to express our answer, so would just be like this. So 7 raised to 2x plus 3 all over ln 49 plus c. Okay, so try to absorb. Okay, so what happened with this one? So we can proceed with the next example. Are we good? Okay. The next one. So we have the integral of e raised to 3x times e raised to 5x all over 7 minus 3 times e raised to 2x. So what's the first step to do with this one? Because obviously we cannot right away so find the integral because there are a lot of things so involved in our integral or integrand. So any suggestion? Wala. Busy nagbibiyahe. Okay. So what we can do with this is we distribute. Okay, so that's the best thing that we can do here. So we distribute e raised to 3x to the two terms. So doing so that would give us multiply that one. So e raised to 3x, so multiplied with e raised to 5x all over 7. Then minus 3 multiplied with e raised to 3x all over e raised to 2x dx. So now we'll have, so e raised to 3x times e raised to 5x, so that is e raised to 8x all over 7. And minus 3 e raised to 3x over e raised to 2x, so we subtract the exponent, so 3x minus 2x is e raised to x, then dx. So we make it 1 over 7, the integral of e raised to 8x dx, and move out the constant or the coefficient, so minus 3 e raised to x dx. So there, in this case, so this is just the integral of EU du, or EU plus c. But our u here is 8x, so our du is 8 dx. So u here is x, so du is dx. So therefore, I can rewrite this one as 1 over 7, the integral of e raised to 8x. However, its derivative, it's 8 dx. So what am I going to do? So I'm going to multiply it with 1 over 8 there, so to neutralize it. But the other one, so there's no problem. So because the derivative of x, it's dx, so there's no need for neutralizing factor. So our answer here then, so would be 1 over, so 7 times 8 is 56. And then EU, e raised to 8x, then minus 3 e raised to x plus c. So 1 over 56 e raised to 8x minus 3 ex plus c. So that is our answer. Yes. Yeah.
Sir, na-confuse lang po. Saan po nakukuha yung neutralizing eme-eme?
Factor. Yeah, so we are getting that one doon sa ano, doon sa du. Okay, so sa du natin kasi, look at this. We have 8 dx. So but in here, it's just dx. So wala tayong 8. So what are we going to do? So we neutralize it by 1 all over 8. So dito kasi walang problema. Nung dinerive natin ng x, it's dx. So which is the same as this. So therefore, wala tayong neutralizing factor because it's the same. So in those case, we apply right away our formula. So kaya meron tayong 1 over 8.
Okay,
So
po,
dun
sir.
sa una. Okay.
Sir, question po.
Yes, question.
Sir, so the integral of function e raised to u is just e raised to u plus c.
Yes.
Thank you po.
So given na yung u mo, pag dinerive mo, makuha mo to. Pag hindi mo nakuha, and then may sobrang constant, so you neutralize it. Okay. So saan po nakuha yung 1 over 8? Ayun. So 1 over 8, yun nga. So that's the neutralizing factor because of the presence of this 8. 8x. Okay. Kasi once we derive that, it's 8 dx. And based on our integrand, there's no 8 dx. It's just dx. So that's why we neutralize it with 1 over 8. Okay? Okay. Okay, so just like what we've done before, I hope you're... Do you have the means to answer this one? And I'm not sure where are you right now. Okay. Anyway, so try to give me an answer after 5 minutes. It's 8:25. So at 8:30, I'll be waiting for an answer. Otherwise, so I'll just answer this one. So kung meron kayong usually mga face-to-face, just like this one, so kung pwedeng mas maaga kayong pumasok, so tapos just stay on the room assigned on our class, then probably you can just, tawag doon na lang kayo mag-attend. And then kahit isang ano lang, so masama na kayo. Or pwede, you can use a laptop, tapos i-project nyo. May projector naman sa room. Okay, 2 minutes. Ayan, pares tayo. Naglalag din ako. Okay. Okay. I think there's a problem with my connection. It's not connecting right now. And
Sir, hello po daw.
Okay. Ayan. So I'm back now. Okay,
Naka-on
so
pa.
let's okay. Ah, nasa school. So let's answer this one. So we have e raised to x 1 plus 3 e raised to x raised to 5. So we are assuming that this is can be solved using power rule. So we let our u so to be equal to 1 plus 3 e raised to x. So our du then so will be derivative of 1, it's 0. So 3 e raised to x, it's 3 e raised to x dx. So that is our du. And since we are looking at the integration of or using the power rule, so we can uh, use the format for the power rule. So that is 1 plus 3 e raised to x raised to 5. And then, so what is in excess here is e raised to x dx. However, using the formula, okay, so for the power rule, so that would be the integral of u raised to n du. So our u, it's 1 plus 3 e raised to x, and then raised to 5. So multiply it with our du. So its derivative, it's 3 e raised to x dx. And what we can see here is, so this line, okay, is not the same as the original integrand. So we multiply this one by 1/3. So to neutralize it. So our neutralizing factor is 1/3. Okay, so because of this one. So now, so we can now use our power rule. So that is u raised to n plus 1 over n plus 1 plus c. So in short, that would be 1/3. Then multiply it with 1 plus 3 e raised to x. So which is our u, n plus 1. So n is 5. So 5 plus 1 is 6 all over 6. And then plus c. So 1/3 times 1/6 is 1 over 18. So multiply it with 1 plus 3 e raised to x raised to 6 plus c. And that's our answer. So who got the correct answer? So merong dalawa, no? Again, Floyd. And what's the other one? Jesse. What's the last name of Jesse? Jesse?
Tunasco po, sir.
Donasco. Okay. Si Floyd, ban muna next time. Dalawa na siya. No? So, iba naman. Okay, so let's have our example number 4. So let's say we have the integral of e raised to 2x minus e raised to negative 2x raised to 2 dx. So can we use the power rule again? So because of the presence of this 2 or this squared as the exponent. So if we're going to use the power rule here, so because of that, so this one will become our u. But if we derive that one, so definitely there's no way for us to get this dx. Okay, so we cannot get that dx alone. Okay, so there would be a variable involved. So particularly, it's an exponential function. So in this case, so we cannot just simply the power rule here. But rather, what are we going to do? So we will be expanding this one. Okay, so this is a binomial expansion. So binomial expansion. So remember in algebra, so we have, let's say you have a plus b, and then raised to 2. So its expansion would be a squared, so plus 2ab plus b squared. And that is what we will be doing here. A is e raised to 2x, and then b is negative e raised to negative 2x. So that will be our a is e raised to 2x, and then raise it to 2. Then plus 2, our a is e raised to 2x, our b is negative e raised to negative 2x. Then plus our b, it's negative e raised to negative 2x, then square it. So then we find its integral. Okay, so we simplify this one, e raised to 2x raised to 2, so that would be e raised to 4x. And then positive 2 and negative, so that would be negative 2. E raised to 2x minus 2x will be 0. And then plus, so negative raised to negative times negative will be positive. Then e raised to negative 2x times 2, it's negative 4x. Then dx. So we could use the sum and difference rule. So this would be the integral of e raised to 4x dx. Then minus, I could move out the 2, the integral of e raised to 0, it's just 1. Or just simply the integral of dx. Then plus the integral of e raised to negative 4x dx. So in here, our u is 4x. So our du is 4 dx. Dito naman, ang u natin is negative 4x. Our du would be negative 4 dx. So rewriting, this would be e raised to 4x. So our formula would be the integral of eu du. So once we have this format, so our answer would be eu plus c. So in this case, we have eu, so which is e raised to 4x. Then what is our du? It's 4 dx. Then comparing it to the original, so we are in excess of 4. So therefore, we are going to attach a 1/4. Okay, so for our neutralizing factor. And minus 2, the integral of dx. And again, so for this one, so the integral of e raised to negative 4x, however, it's du, it's negative 4 dx, negative 4 dx. So therefore, we have to neutralize it by the reciprocal of that, so which is negative 1/4. So finally, giving us the answer to be, so ito lang formula natin, eu plus c. So 1/4 e raised to 4x, and minus 2, the integral of dx is just x, and minus 1/4 e raised to negative 4x plus c. So this now will be our final answer. So in this case, we expanded it first, okay? So rather than using a power formula, because that will not be applicable. So we just expanded, okay, so our given integrand. Question? Okay. Number 5. So number 5, we have another form of the exponential function with the base of a constant. So if we are given a ratio, so we've mentioned before that if it is a ratio, one thing that we can try would be the natural logarithm, because the denominator, okay, so its power collectively, so that would just be 1. However, for it to become a natural logarithm, so once we derive the denominator, we should be able to get the numerator. And deriving 4x, 4 raised to x, so definitely we cannot get the 5 raised to x plus 3 raised to x. So what we will be doing is, it's not possible, okay? But rather, so we can perform the operation involved there. Okay? So there is a division involved, so we can divide. So this one can be rewritten as the integral of 5 raised to x over 4 raised to x, and then so plus, so 3 raised to x all over 4 raised to x dx. Okay, so we separate this one into 2 terms. Okay, so 5 raised to x over 4 raised to x, and plus 3 raised to x over 4 raised to x. And then remember this one in the properties of exponent. So let's say we have a over b, and then raise it to n. So this is the same as a raised to n all over b raised to n. So this is the format of the 5 raised to x all over 4 raised to x. It's the same as a raised to n all over b raised to n. So in this case, so we can just get the 5 over 4 first, and then raise it to x. So since x is common, and then plus 3 over 4 raised to x, and then multiply it with dx. So simply put, this is just the integral of 5 over 4, so raised to x dx, and then plus the integral of 3 over 4 raised to x dx. So it's our formula. The formula is a raised to u du is equals to au over ln a plus c. So in this case, our u is x. So both of them has a u which is x. So its derivative, it's dx. So therefore, we can just right away use this formula. So that would be our a is 5 over 4, and then raise it to x all over ln a. Ln, our a is 5 over 4. And plus 3 over 4 raised to x all over ln of 3 over 4 plus c. So we have that answer. So 5 over 4 raised to x all over ln 5 over 4 plus 3 over 4 raised to x all over ln 3 over 4 plus c. So are we good? Or there's a need to clarify something? Okay, so there's none. So I'll proceed with number 6. So number 6, there is a ratio involved. Okay, so there's a ratio involved, so we can either use the power rule or the natural logarithm. The natural logarithm, so the power of the denominator should be 1, or the function at the denominator should be 1. But if it is other than 1, then most probably that will be a power rule. So in this case, the denominator is, or it has a power of 1/2. Okay, so because of the radical. So in this case, so I would rewrite this one as, I can move out 8. So 8 is constant. So the integral of e raised to x, and then 3 plus e raised to x. So divide it with, so this one would become e raised to 2x plus 6 e raised to x plus 1. So I'll make it as a rational exponent. So that is raised to 1/2. And multiply it with dx. But if we are suggesting that this would be a power rule, so therefore we have to move up the u raised to n. So this one would become e raised to 2x, then plus 6 e raised to x plus 1 raised to negative 1/2. And then multiply it with e raised to x, 3 plus e raised to x dx. Okay, so now that we were able to rearrange it, so let's try to see if it's really a power, or we can still use the power rule. So our u here is e raised to 2x, then plus 6 e raised to x plus 1. So we derive this one. So derivative of eu, it's eu du. So our u is 2x, so its derivative is 2. So therefore, this one is 2 e raised to 2x. Then plus derivative of 6 e raised to x, it's still 6 e raised to x. 1 is 0. Then we multiply everything by dx. So rewriting this one, so look at our du as well as this one. So they have a resemblance, however, they are not totally the same. But rather, I need to factor out something to make them equal. So what is common on our differential u? So for 2 e raised to 2x plus 6 e raised to x. So common is it's our common factor for 2 e raised to 2x plus 6 e raised to x. Two e raised to x. So 2 e raised to x. So 2 e raised to 2x. So divide it with 2 e raised to x. So it will just be e raised to x. And then 6ex divided with 2ex. So that will just be 3 dx. So which is the same as this, except I will just have 8, the integral of e raised to 2x plus 6 e raised to x plus 1 raised to negative 1/2. So again, so our formula would be integral of u raised to n du. So ito muna tayo, u, then n is negative 1/2. What's our du? So the du is 2 e raised to x, then e raised to x plus 3 dx. So which is exactly the same as the one above, except for 2. So therefore, we divide this one by 2. So because of this, so we have a neutralizing factor of 1/2. So in the end, so this would be 8 over 2, that would be 4. And then we use the formula here, which is un plus 1 all over n plus 1 plus c. So thus, we have 4 multiplied with u. Our u is e raised to 2x plus 6 e raised to x plus 1. And then negative 1/2 plus 1. That would be negative 1 plus 2. It's positive 1. And then divide it with 2 over 1/2 plus c. So 4 divides 1/2. That's just simply 8. Kasi reciprocal mo yung 1 over 1/2. That is 2. 2 times 4. We have 8. And then we have 8 multiplied with e raised to 2x plus 6 e raised to x plus 1 raised to 1/2 plus c. If you want to make this one as a square root, that is okay as well. So this is power rule involving exponential function. Okay? So are we getting the idea? Okay, so it's either you understand this one or you're busy traveling. Anyway, So let's have example number 7. So which is our last example. So we have the integral of the cube root of 27 e raised to 9x plus e raised to 12x. This one is not included. So let's just multiply it with dx. So again, so if we are given radicals, so we rewrite this one as 27 e raised to 9x and then plus e raised to 12x and then raise it to 1/3, then dx. So again, we can use the power rule, okay, so as suggested. But again, if we're going to right away, so use the power rule, and then the 27 e raised to 9x plus e raised to 12x will become right away our u. So there's no way for us to just get dx. Okay, so that's very a complex value for u. So what we're going to do is, let's try to factor out first the term inside the radical sign. Okay, so because there's something factorable inside. So what is that one? So that is the e raised to 9x. Okay, so e raised to 9x is factorable. So the integral of, so I'm going to factor out e raised to 9x. So 27 e raised to 9x divided with e raised to 9x, I will just have 27. Then plus e raised to 12x divided with e raised to 9x. So 12 minus 9, so that would be 3x. So e raised to 3x. So all of those are raised to 1/3, then dx. Then again, rules in algebra. So let's say we have a, b, and then raise it to m, raise it to n. So this is the same as a raised to n, b raised to n. So in this case, so this one would serve as our a, so this would serve as our b. So we just distribute b n. Okay, so or we exponentiate both a and b. So that will become e raised to 9x and then multiply it with 1/3 or raised to 1/3. Then multiply it with 27 plus e raised to 3x and then raise it to 1/3 and multiply it with dx. However, e raised to 9x raised to 1/3. So we just multiply. So 9x times 1/3, that is e raised to 3x. And multiply it with 27 plus e raised to 3x raised to 1/3. And then all of this multiply it with dx. So this time, so since I'm assuming that this will be solved using power rule, so we use the format of the power rule. That is the u raised to n du. So its answer would be u raised to n plus 1 over n plus 1 plus c. So its format then, so we'll start with u, so which is 27 plus e raised to 3x 1/3. So rearranging this one, and then leaving us to only have e raised to 3x dx. Okay. So now that we have that, so our u then, so will be, we're assuming that that is 27 plus e raised to 3x. Our du then, so 27 will be 0. Then e raised to 3x, it's eu du. So eu is e raised to 3x. So derivative of 3x, that is 3 dx. So following this formula, okay, so u raised to n, that would be 27 plus e raised to 3x raised to 1/3. However, the du is this one, so which is 3 e raised to 3x dx. It's not the same as the original integrand, so therefore we multiply it with the neutralizing factor of 1/3. And thus, we can now use the power rule. So that is 1/3. So multiply it with 27 plus e raised to 3x. So 1/3 plus 1. So 1 plus 3 is 4 all over 3. Then divide it with 4 over 3 and plus c. So again, so this is 1/3. And then 4 over 3, its reciprocal is 3/4. 27 plus e raised to 3x raised to 4 over 3 plus c. So 3 will be cancelled out. So leaving us for the final answer to be 1/4 and times 27 plus e raised to 3x raised to 4 all over 3 plus c. Okay. So 1/4 27 plus e raised to 3x raised to 4 over 3 plus c. Question? Okay. So that would be our last example. Let me stop the recording.